I will share to you this time about compound interest, particularly compounding more than once a year. Sometimes, interest may be compounded more than once a year. Consider the following example. Given a principal of 10,000 pesos, which of the following investment schemes give you more earnings at the end of 5 years? A. 2% compounded semi-annually, or B. 1% compounded monthly. Take a look that for letter A, the rate of 2% is compounded semi-annually, but on the second investment scheme, the 1% is being compounded monthly. If ever it's you who will be the one to choose between these two investment schemes, what would you choose? A or B? Before you answer, let us solve the amount. Let us familiarize ourselves with the following terms first. Frequency of conversion, or M. This refers to the number of conversion periods in 1 year. For example, if it is semi-annually, annually, monthly, quarterly, or daily. Conversion or interest period refers to the time between successive conversions of interest. Total number of conversion periods, or N. And this is solved by multiplying the frequency of conversion and time in years, or the formula for finding N is MT. Nominal rate, or IM, is the annual rate of interest, and the rate J of interest for each conversion period is solved by dividing the annual rate of interests over frequency of conversion. Note on rate notation. In earlier lessons, R was used to denote the interest rate. Now that an interest rate can refer to two rates, either nominal rate or rate per conversion period, the symbols IM, or the nominal rate, and J, or the rate per conversion period, will be used instead. Here are some examples of nominal rates and the corresponding frequencies of conversion and interest rate for each period. So we have here the nominal rate, the frequency of conversions, and the interest rate per conversion period. For example, we have 2% compounded annually, so that would be I1. It's because 1 is annual and it's 0.02, so M is just 1 since it's annual. Then semi-annually is 2, and take a look, ang atong M diri gilisan pod og 2. Quarterly, so it's 4, I4. Then monthly, it's 12, and then daily, it's 365. For the interest rate per conversion period, the formula there is to divide the nominal rate and the frequency of conversion. So you can see that the frequency of conversions do matter for the interest rate per conversion period. Let us find the maturity value, or the future value, for compound interest, particularly compounding M times a year. If interest is compounded more than once a year, the formula is this: F equals P times 1 plus J to the power of N, or F equals P times quantity 1 plus IM over M raised to an exponent of MT, where F is the maturity value at the end of the term, P is the principal or the present value, IM is the nominal rate of interest, and then T is the time or term in years, and M is the frequency of conversion. To find J, you just have to divide IM over M, and to find N, you just multiply M and T. Let us apply the formula in the example that I've presented earlier. Given a principal of 10,000, which of the following investment schemes give you more earnings at the end of 5 years? Let us solve this 2% compounded semi-annually first. So identifying the given, we have the principal, which is 10,000. Frequency of conversion is 2 since it's semi-annual. And then nominal rate is I2 is 2%, and term is 5 years. I will be showing to you how to solve the maturity value using the first and the second formula that I've mentioned or I've presented a while ago. So for investment A, I will use the first formula. I will have to solve J first. J is the rate per conversion period, and it is solved by dividing the nominal rate and the conversion period. So we have 0.02 over 2, and that is equivalent to 0.01. The total number of conversion periods is solved by multiplying the frequency of conversion, 2, and the term, 5 years. So that's why it's 2 times 5. It is therefore 10. This is our formula, and substituting the given data here, we have this. J is 0.01. This is the rate per conversion period, and 10 is the total number of frequencies. 1 plus 0.01 raised to an exponent of 10 is equivalent to 1.104622125, and then multiplying it to 10,000, that is equivalent to 11,046.22. You may check this using your calculator. And by the way, it's better to copy everything when you raise a number to a particular exponent so that the result would be more accurate. It would be better to round at your final answer already, not on the prior steps, okay? So this is the future value for our first investment. Now, on the second investment, we have 1% compounded monthly. This is the offer. So taking account into the given data, same with the principal, and since this is already monthly, so the frequency of conversion period is 12. The nominal rate is 1% or 0.01, and take a look, it's already I-12. Term is the same, 5 years. In this investment scheme, I use the second formula like this, but actually it is just the same with the first one. Substituting the values to the variables we have here, IM is our nominal rate, which is 0.01, and M is 12. M is 12, this is the frequency of conversion period, and 5 is the term. So we have this line. Solving this quantity, 1 plus 0.01 over 12 raised to an exponent of 12 times 5 yields 1.051249207. And multiplying it to 10,000, we have the future value, which is equivalent to 10,512.49. Now let's take a look which investment scheme would give you more earnings. For investment A, we have the future value or the maturity value of 11,046.22. While for investment B, at 1% compounded monthly, you will just yield an earning of 10,512.49. Now that we have solved both investments, then investment A at 2% compounded semi-annually will yield more earnings than investment B. Therefore, it's better to choose this investment scheme than the second one. In finding the maturity value for compound interest, and that interest is compounded more than once a year, you may use this formula or this formula. Just be careful in identifying the number of frequency of conversion, the nominal rate, and of course the rate per conversion period, because again, these matters in the computation. One simple error in identifying the data will give you an incorrect answer. Good luck and have a great day!